I want to investigate a case where the two cars stick together, but neither of them is at rest. So in this case, what we'll do is we'll take this car and move it to the right, and we'll take this car and move it to the left, and they will collide. Velcro is still here, so they will still stick together. And what we'll do is what I'm going to try to do, I don't know if this will work, I'm going to try to make the car on the left, this side, move fast, and this one move slow. And we'll see how that works. So let's see what happens. Alright, that worked alright. So let's do the momentum math and see what happens and see if what we saw made sense. So we saw two different cars again, still equal mass, 2 kilograms and 2 kilograms. And we had them moving towards each other. So this one moved in this direction and this one moved in this direction. The one on the left was moving fast. So let's say that it moved with a velocity of 5 meters per second to the right, and this other car on the left moved slow, so let's say it moved with a velocity of 2 meters per second, and it was moving to the left. After the collision, what did we see? Again, the cars stuck together. So cars stuck together, still 2 kilogram cars, 2 kilogram cars, and what did we see is we saw that both of them were moving in this direction, but again with an unknown velocity. So we want to actually find out what that velocity was and see if it is between 2 and 5 or what happened. So standard procedure, momentum is mass times velocity plus mass times velocity. So in this case we have 2 kilograms times 5 meters per second for the first car plus 2 kilograms times, and here we're going to be careful, the velocity in this case we said was 2 meters per second, but we also said that it was directed to the left. So it is going in the opposite direction, so we're going to say that this is going minus 2 meters per second, because we know that velocity has direction, and the direction is important. And since velocity has direction, and velocity is in momentum, direction will also be important for momentum. So here we end up with 5 times 2 is 10 kilogram meters per second, and here we end up with 2 times 2 is 4, so minus 4 kilogram meters per second because of that negative velocity. So my total momentum before the collision ends up being 10 minus 4 is 6 kilogram meters per second. What about after the collision? So let's go back over here to after the collision and do our same procedure. Momentum is mass times velocity. Because these are all stuck together, I'm going to have 2 kilograms plus 2 kilograms times my unknown velocity that I don't know. So I'm going to end up with 4 kilograms times the velocity. And again, conservation of momentum says the momentum beforehand, the momentum afterwards is going to be equal. So my 6 kilogram meters per second is equal to 4 kilograms times my velocity. Divide both sides by 4 kilograms, divide by 4 kilograms, and I end up with a velocity equal to 1.5 meters per second. And now we can look at this and we can interpret, and of course it probably brings us more questions than we have answers, but that's okay. Look at what happens. We have a final velocity of 1.5 meters per second. We remember that direction is important. Since this is positive, we realize that, oh, the direction is important, it's positive, so it'll move to the right. If this answer came out to be negative, we would expect that this, after the collision, would move to the left. And we can actually test that if we want to. We can try it in a second. The other thing that we notice is if we look here before the collision, we have 10 kilogram meters per second worth of momentum for the first car. We have negative 4 kilogram meters per second of momentum for the second car. I might wonder what would happen if both of these guys had the same amount of momentum. If I had 10 kilogram meters per second for one car and negative 10 kilogram meters per second for the other car, I would end up with 0 momentum. What would happen on the other side? If I had 0 momentum here, presumably this would stop. So those are a couple of situations that we can actually try and see what happens. So let's do the math, let's do it backwards. Let's do the math first this time and see what happens if the car on the right is faster. So let's just do it real quick right here. We can say, here's my two cars, 2 kilograms, 2 kilograms, and let's say that this has a velocity of 2 meters per second, and this one has a velocity of 5 meters per second, but let's make the 5 meters per second going to the left faster. And after the collision, they'll be stuck together, and so we'll have 2 and 2, and we'll find out what the velocity is. So in this case, momentum is mass times velocity plus mass times velocity. We're getting kind of bored with this now because we're doing it so often. We end up with 2 kilograms times 2 meters per second, and it's moving to the right, so this velocity is positive, plus 2 kilograms times negative 5 meters per second, and it's going negative because it's going to the left. So I'm going to end up with 4 kilogram meters per second minus 10 kilogram meters per second equals minus 6 kilogram meters per second. And after the collision, I'm going to get momentum equals 2 plus 2 is 4 kilograms times the velocity. And because of conservation of momentum, I'm going to say that these guys are equal. So minus 6 kilogram meters per second equals 4 kilograms times velocity. Divide by 4, divide by 4. I'm going to end up with a velocity of minus 1.5 meters per second. So the difference, if my velocity is bigger moving to the left, then I'm going to end up with a negative velocity, and I'm going to expect that these carts are going to move to the left. So let's look at those situations. Faster cart is the one to the left. Let's see if it ends up moving to the left, and then we'll see if we can make them equal and see if we can get them to have 0 momentum. In this case, we're going to move them, and I'm going to try to make the car that's moving to the left, so the car on the right that's moving in this direction, I'm going to try to make it move faster, and the other car to move slower. So we'll start this car first, and it's moving slower. And the car that was moving faster was moving this way, so we ended up with a negative final velocity. So that matches with what we just did mathematically. The next question is, what happens if they both have the same velocity, but in opposite directions, and then they stick together? Let's see if we can do this, and we end up with, well, not quite. So this one ended up with a little bit higher velocity. Let's try one more time. This will be hard to do just manually. This one was faster. All right, let's try one more time. Now I'm feeling the challenge. It's close. But you can see what happens. The more equal they are, the more likely they are to stop and have all the momentum canceled out, because one has positive momentum and one has negative momentum.